Hello, dear colleagues. I'm Iryna Yepifanova and my also Viacheslav Dzhedzhula, Vinnytsia National Technical University, and let me present you our results on the topic of increase in the energy efficiency of the biogas production process through vibration activation of heat and mass exchange processes in the bioreactor. So, in the course of anaerobic fermentation of biogas, in biomass, it is necessary to observe certain limits of temperature regimes. At the same time, the speed of movement of the substrate under the conditions of the optional fermentation process should not exceed the data of 0.7. The expansion of the development of biogas plants requires a reduction of their capital and operating costs. One of the important problems preventing the increase in energy efficiency of biogas reactors is the use of heating elements operating in the free convective mode of heat exchange. In addition to the large heat exchange areas and the correspondingly reduced useful volume of the reactor, the use of free convective heat exchanges leads to the formation of stagnation zones, stratification of the medium, hypercooling of the lower zones of the reactor, overheating of the upper zones. The method based on the vibration of the environment is the most suitable for the conditions of the biogas plant, since in addition to the intensification of heat transfer, additional mixing takes place. Also, among the most effective methods of increasing the intensity of heat exchange when liquid flows around borders is the vibration of the moment, which provides under optimal conditions. Also, the equation of motion of the activator plate can be found by solving the Lagrange equation. And having entered the coordinate system as shown in figure 1, we write down the kinematic relations between the components of the activator mechanism and the velocity equation, provided that instantiation center of the velocity is some point. Here you can see equations which we write down for describing the value of generate force of different works and the kinetic energy. And also we will solve the system using Röntgen numerical method, and we obtain a solution in the form of values of the function. And using the solution of system 26, it is possible to determine the value of the speed of the activator plate. The liquid under the action of the plate also begins to take oscillatory moments and washes the heat exchange surface. A wall layer is located around the heat exchange surface, which heat transparent mainly due to thermal convectivity, figure 2. According to Fourier equation, we write that the heat can be determined by different equations, which you can see at this slide. Also, based on the results of analysis of the developed mathematical model, it has been found that in the range of measurements, the obtained value of the increase in the coefficient of heat transfer from the horizontal heating tabular element to the water exceeds the value for free convection by the average of 1.5 to 2.8 times. Both medium fluctuations and heat flow have a significant influence on the intensification of heat exchange. Here you can see the laboratory where experiment was made, and also you can see figure 3, the surface of the influence of the Reynolds and Prandtl criteria on the value of the Nusselt criteria using vibration, activation, or heat exchange. So the law of motion of the activator plate has been found by solving Lagrange's differential equation. Based on the laws of thermal conductivity, convective heat and mass transfer, and convention of moment, a criterion equation has been developed that describes the heat exchange processes between the heating element of the substrate during oscillatory washing of the heater wall. Based on the results of the analysis of the influence in the fluid oscillation created by the moment of the activator plates on the intensity of heat transfer from the wetting wall to the water and the substrate, the choice of the determining temperature of the liquid and the temperature of the wall, which different methods of organizing convection is subtracted. It has been found that the oscillation of the medium by the activator plate intensifies the free convex heat transfer in the aqueous medium by 1.53 times. And thus, the use of the activator plate to intensity heat exchange in bioreactors allows thermostabilization and intensification of the biogas production processes and saves material resources by reducing the area of heat exchange devices. So thank you for your attention. My report is finished.